The first method is integration by substitution. The second method is integration by partial fraction. And the last method is integration by parts. So let us discuss the first one, because today's lesson it's all about integration by substitution. Now, in integration by substitution, what we will be needing is we will be needing all the differentiation formulas which we have learned. So basically what I will do is, so we are going to discuss this topic today. So integration by substitution. So I will just talk about what is the basic idea behind this integration. So the basic idea behind this integration is that, so what you have to do, for certain problems I need to search a function where the function is also present as well as the derivative of that function is also present. Okay, so suppose I will give you an example. An example goes like this: integration of sin x by cos x. Sin x by cos x. So what I told you, I will use integration by substitution on those problems in which I see the function as well as I see the derivative of the function. Okay, if I see both of these two are present in the problem, then we can use method of substitution. And what we will do, I will tell you. So look at here, if I look at this problem, in this problem the function is what? So this inside one is the function, right? So here two terms are there, one is sin x and the other one is cos x. So if I take sin x as my fx, if I take sin x as my fx, then the derivative of sin x is also present in this problem, that is cos x. So both the function is also there, I'm just assuming. So sin x is also there and the derivative of sin x is also there. So it means that I can use method of substitution to solve this problem, because sin x is there and derivative of sin x is there. Am I clear? So if those two, hey, mute your audio. Now the next question. Let us take next example. Suppose I have integration of sine inverse x divided by root over of 1 minus x square. Now I have a different problem. Now look at this question. Again, I will search for a function and its derivative. If both of them are present, then we can use method of substitution. Now look at here. If I look clearly, I have sine inverse x and I have 1 by root over of 1 minus x square. I know that if I take sine inverse x as the function and derivative of sine inverse x is what? 1 by root over of 1 minus x square. So once I see these two things, so we can say what? We can apply method of substitution in here also. Understood? Acha, fine. I will give you another example. Let us give you another example. Suppose I have tan x x square x. Can I use method of substitution? Yes, I can use method of substitution. Why? Because if I take tan x, derivative of tan x is what? Derivative of tan x is sec square x. So I can apply method of substitution. Am I clear? Please tell me yes or no. Am I clear? Where can I apply method of substitution? Yes or no? Yes. So now let us try solving the problem. Now let us start with question number 1. Let us start solving question number 1. So here the first 7.2. Here we'll start question number 1. Sin x into cos x. Integration of sin x into cos x. Mute your audio. So let us solve this one. So I told you what? If I have sin x and derivative of sin x, so we can use method of substitution. Now what is this method of substitution? Now I will tell you. Substitution is nothing but I will take sin x and I will write sin x as let sin x is equal to t. I will substitute it with another variable. I will write sin x is equal to t. Okay? Clear? Then what I will do is I will differentiate the sin x. So differentiating with respect to x. Differentiation of sin x is what? Cos x. And differentiation of t is what? Dt dx. Right? Now you see, if you look at the problem, I will replace sin x with t, but what I will do with this dx? What I will do with dx? So if I look at this step, in here we have what? Cos x is equal to dt dx, right? So I will take this dx the other side. So I will write therefore dx is equal to, I can write this one as dt by cos x. I will just write dt by cos x. So I will write cos x in the denominator. So basically we are getting 1 by cos x dt. So these are the two things we are getting. What are they? I will replace sin x, I will substitute sin x with t, and I will replace dx with dt by cos x. I will replace dx by dt by cos x. So let us do this one in the problem and see what you get. So therefore, I is equal to what? I is my this one. So right here, I. Therefore, I is equal to what? I is equal to integration of, in place of sin x, what I will write? T. In place of sin x, I will write t. Now cos x, I will do nothing. I will do nothing with cos x. I will leave cos x like that. And in place of dx, I will write what? Dt by cos x. I will write dt by cos x. And now you see, cos x goes out. So what we have? We have integration of t dt. Integration of t dt. And what was that? Integration of x to the power n dx. What was that we have learned last class? It was x to the power n plus 1 divided by n plus 1 plus c. So integration of x dx is what? Integration of x dx is what? It is x to the power 1 plus 1 divided by 1 plus 1 plus c. So x square by 2 plus c. So here integration of t will be what? It will be nothing but t square by 2 plus c. That is what integration of t is. Now what is t? T is my sin x. Now I will put the value of t in here. So I got my answer as sin x whole square by 2 plus c. That's my answer. So that's how we use method of substitution to solve a problem like this. Okay? Clear? So let me do some problems, then we'll get the idea of it. Okay, let's do exercise 7.2. Let's go to exercise 7.2. 7.2 question number 1. So here what we have to integrate 2x divided by 1 plus x squared. So we have to integrate this one. Hey, mute your audio. Mute your audio. So we have to integrate what? 2x by 1 plus x squared. Now, can anybody tell me what should I substitute in here? Let's see who can tell me. Who can tell me? Look, I have substituted sin x. Why? Because differentiation of sin x is what? Cos x. So in here, in the second problem, what should I substitute? Whose differentiation is also present? Very, very good. I will substitute 1 plus x square. Why? Because derivative of 1 plus x square is 2x. So both are present. So write down. So let 1 plus x square is equal to t. I will substitute with t. Now differentiating with respect to x. Differentiating with respect to x. What do you get? Here it is 2x. And differentiation of t is dt dx. Now I told you what to do. Now we will find dx. Dx is equal to what? Therefore, dx is equal to dt by 2x. 2x will come down like this. Now I will become what? So my I will become I is equal to integration of this 2x, the 2x in the numerator, I will do nothing. I will just leave it like this. 2x divided by, in place of 1 plus x square, I will write t. And in place of dx, I will write dt by 2x. So this 2x goes out. So we have integration of dt by t. Can anybody tell me what is the formula of this one? Integration of dt by t. Who can tell me? It is log of mod t plus c. Okay, because integration of 1 by x is log x. So integration of 1 by t is log t plus c. Don't forget to write c. And what is t? T is 1 plus x square. So I will write here log of 1 plus x square plus c. That's my answer. Okay. Now let's move on to question number 2. Question number 2, what we have? I is equal to log x whole square divided by x dx. Acha, okay. Uh, so tell me, what should wait? Who should I ask? Rosalind will tell me now. All of you done? Yeah. So Rosalind, please tell me, what should I substitute in this question? What should I substitute in this question? Integration of log x whole square by x dx. Tell me fast. What should I substitute in this question? It's only possible if we know all the Uh-huh. Yes. Look, we know differentiation of log x is what? Differentiation of log x is what? It is 1 by x, right? Yes. So once I see that differentiation of log x is 1 by x, so I see both of them in here. Log x is also there and 1 by x is also there. So I will substitute log x. All I have to do is search for a function whose derivative is also present in the question. So I will write let log x, why am I giving brackets? Let log x equal to t. So differentiating with respect to x, differentiating with respect to x. So what do you get? Differentiation of log x is 1 by x and differentiation of t is dt dx, right? So let us find dx. So therefore dx is equal to, now look at here, sir, why not log x whole square? Look, acha fine. Suppose I am substituting in log x whole square. Now you see, if I differentiate log x whole square, what do I get? We get 2 log x, we get 2 log x 1 by x dx, right? So we are getting another log x term. If I substitute, now if I use this one, it is equal to dt. Achha, wait a second. Let me remove the confusion nicely. So you are telling me to substitute log x whole square as t. So if I substitute this one, now if I differentiate, we get what? 2 log x, 2 log x, then 1 by x is equal to dt dx, right? We get this thing, right? After getting this one, we will write what? Dx is equal to x dt divided by 2 log x. Now, if I put this one in the answer, so my integration will become what? My integration becomes log x whole square is what? You have told me to substitute t. So I will write t. So t divided by x and the dx will become what? The dx is what? X dt divided by 2 log x. X is goes away. What about this log x? This log x still remains, right? Actually, this is also correct. Why? Because this log x, what I will do is, log x whole square is t, right? So I can write this one as square root of t is equal to log x. So in here I can employ square root of t, but it is too much confusion. Okay, so there is square root is there, t is there, that is also correct. But you see, this one is easily done. Okay, in place of log x, you just have to write square root of t because there will be a log x term in there. Now, let us do this one. So, therefore, dx is equal to x dt. We have x dt in here. Now, we'll see. Always we will try to substitute that term whose differentiate, whose, what should I say, clear derivative is present. So, I have taken log x as t. Why? Because the derivative is 1 by x. So, I can clearly see that thing. That's why I substituted log x. So, I will write I. So, I becomes what? I is equal to integration of, now I see log x whole square, so it will be t square divided by x, I will not do anything with x, into, in place of dx I will write x dt, so x goes away, so we have integration of t square dt. And what is integration of t square dt? I told you already, it will be t to the 2 plus 1 divided by 2 plus 1, t cube by 3 plus c. That's a very, very important formula. You must remember this one. So this is the answer. Achha, no, that's not the answer. We have to write t, right? So t is what? T is log x. So it will be log x whole cube by 3 plus c. This is my answer. Mute your audio. That's my answer. Okay. Achha, this is what we got. Hmm, question number three. Question number three. Acha, question number three. I will not do the entire question. Can anybody tell me what should I do in here? In question number three, what should I substitute, or what should I do? Tell me first. 1 plus log x. How are you sure? Acha, in question number 3, what I do is I will take x common. I will take x common between both of them. So if I take x common, I have 1 plus log x. I have 1 plus log x dx. Now you see, if I substitute log x as t, if I substitute log x is equal to t, I will get what? 1 by x. So my problem is solved. But you see, if I substitute 1 plus log x as t, then also it is 1 by x. Because differentiation of 1 is what? 0, right? So I will substitute 1 plus log x as t. Am I clear? So I write let 1 plus log x is equal to t. Then I will solve the question. So differentiating with respect to x, we get what? We get 1 by x, and this side we get dt dx. So I will do what? I will find out dx is equal to x dt. So then we will substitute and we'll find the answer. I don't want to complete this problem because it's too easy. It's just like substitution. It's so easy. Acha, let's go to question number 4. Let's go to question number 4 because there is no fact in doing these questions again and again because they are the same questions. Sin x, sine of cos x. What should I substitute? Acha, now all of you tell me. What should I substitute in here? Sin x, sine of cos x. What should I substitute in here? Look at it carefully and then tell me. So we can see two terms. We can see sin x and we can see sine of cos x. So what should I substitute in here? Think and answer. Come on. Come on, try. Acha, look at here. So what we will substitute is that, look, in here sin x is outside, right? And sine of cos x. So in here what should I substitute is cos x is equal to t. Why? Why I will substitute cos x is equal to t? Because differentiation of cos x is what? Sin x, right? So this sin x can go away. Clear? But yeah, I know it's minus sin x. We can do it, but I'm just saying because in here there is sin x. Yes, that's right. So I'm sorry. Yeah. So I write here let cos x is equal to t. I cannot write sin x is equal to t. Why? Because differentiation of sin x is cos x. But here the cos x is not alone. Cos x is inside sine. So we cannot substitute sin x. We have to substitute cos x. So let cos x is equal to t. So differentiating with respect to x. So what you get? Minus sin x is equal to dt dx. Now we have to find dx. So therefore dx is equal to, it becomes dt divided by minus sin x. This is what we have. So I need to substitute this one and I need to substitute this one. So let us do it. So I will write therefore I is equal to integration of sin x will remain as sin x. I will not do anything with sin x. Then I have sine of cos x. So it will become sine of t. It will become sine t. Then dx will become what? It will become divided by dt divided by minus sine x. So let's cut sine x and sine x goes away. So this minus will basically come out and we have integration of sine t dt. And integration of sine t is what? Integration of sine t is minus cos t. Please remember these formulas. Integration of sine t is minus cos t. So this minus minus becomes plus and cos t. T is what? Cos x. So I have cos of cos x plus c. That's my answer. That's how we solve this question. Acha. So question number 4 is done. Question number 5. Question number 5 is also very easy. So question number 5, what we have is I is equal to integration of sine of ax plus b and cos of ax plus b. So we have this thing. Okay. Now this one is very, very easy. Why it's very, very easy? Here we have two functions. It's just like the example I told you. Either you can substitute sine ax plus b is equal to t, or you can substitute cos ax plus b is equal to t. Why? Because they are interlinked to each other. Because differentiation of sine x is cos x, and differentiation of cos x is minus sine x. So let us do that. So what I will do is I will not worry with the minus sign. So I will substitute, yes, let, why should I use the formula? What's the purpose of it? It will be too confusing to use the formula of sine a plus b. Because if I put the formula of sine a plus b, it will be way too longer. I will just substitute sine ax plus b is equal to t. I will substitute sine ax plus b is equal to t. Then my integration will be done. What's with your voice, huh? So sine ax plus b is equal to t, I substituted. Now we will differentiate. Differentiating with respect to x. So what you get? Differentiation of sine ax plus b is what? It is cos ax plus b. Now don't stop here. Most of you will stop here. Differentiation of ax plus b is what? A. So I need to have a in here. And that is equal to dt dx. So what is dx is equal to? Therefore, dx is equal to dt divided by a cos ax plus b. This is what we have. So the two substitutions are this one and this one. So let us have our I. So I will become what? Integration of, in place of sine ax plus b, I will write t, and cos ax plus b will this one only. Then dx will become what? Dx will become dt divided by a cos ax plus b. So let's cut this one goes, and this 1 by a will be taken out. I will take it outside, and we have integration of t dt. And we know integration of t is what? T square by 2. So we have 1 by a t square by 2 plus c. Basically, we should have written t square by 2a. So now in place of t, what I will write? Sine ax plus b. So I have sine square ax plus b divided by 2a plus c. That's it. So this is how we solve the problem. There is no need of doing sine a plus b formula in here. Okay, clear? Now, let's move on to question number 6. Now, very, very important question number 6. No, it's not, it's important because it's a different type. It's a different type of question. Can anybody tell me what should I Yes. What's with the number of 5? What's the answer? Yeah. Okay, one thing I tell you guys, I told you what integration is what? Integration, indefinite integration is what? They will not give you, is it 1 by 4? How come it 1 by, how it comes 1 by 4? It has to be 1 by 2. From where 1 by 4 will come? There is only t in here. Obviously, it's coming t square by 2. It will be 1 by 2a. Look, I will tell you one thing. Indefinite integration is what? Because it does not give any definite value. The value of integration can be different. Now look at here. If we would have substituted in here cos ax plus b is equal to t, we would have had a different answer. The answer would have been different. Okay? The answer would have been this one, minus cos square a, the one which you're telling in your book, this one would have come. But it won't be 4a. I'm 100% sure it will be 2a. How come it will 4a? It is integration of t, right? It's all, yes, yes, yes. There are another formula you can use. Look, indefinite integration, there are different ways of solving. Understood? There are many ways of solving, and it's all about, that's why it's called indefinite. The answer can be very it can be different. It's all about the method, whether your method is correct or not. If your method is wrong, obviously your answer will be wrong. But if our method is correct, then the answer is correct, no matter the answer is different from the book, because the approach may be different. That's why it's called indefinite integration. Yes. Which answer? This answer which I got, it's 100% right. That's why, and if you have doubts, then you try to, acha, fine. Do one thing. The one you are doing, telling me by trigonometry, you're telling me, you solve it and send it, you solve it and send it to me. I will check. If you understood that one, you can use that method. No worries. It's all, it, wow. So it's all about the method. If your method is correct, that's it. Acha, now, integration of root over of ax plus b. How should I do this one? Tell me. What should I substitute in here? Now listen very carefully. Here I don't see any derivative, anything in here. So my one suggestion for this type of problem is, so please remember this one, a very important. Whenever you see square root, whenever you see square root, what you do is, whatever is inside the square root, take it as t square. That's a simple thing. Whenever you see a square root, there will be some exceptions, but whenever you see square root and you have no other way to go, you do what? You substitute whatever is inside the square root as t square. Simple as that. You don't have to do anything. You substitute whatever is inside the square root as t square. Now this is one of the type, so please remember this one. Please do remember this one. Okay, clear? So let's start solving this question. So I will write, let ax plus b is equal to t square. I'm going to substitute this one. So what do I get? Now differentiating with respect to x, what do I get? So here we get is, differentiation of ax plus b is what? A. And differentiation of t square is what? 2t dt dx. This is what we have. Right? Now we have to find dx. So dx is equal to 2t by a dt. This is what we have. Now we'll substitute in there. So I is equal to what? Let us write I in here. So I is equal to, now square root of ax plus b is what? T square. So I write here t square. Then dx is what? 2t by a dt. Clear? So what we have, this 2 by a I will take out, 2 by a taken out. Then square root of t square is what? T. This t and this t will become t square dt. Okay? And I know you are well aware that what is integration of t square? Integration of t square is t cube by 3 plus c. So what I get? 2t cube 2t cube by 3a plus c, and in place of t what I will write? Now that's the thing. In place of t what I will write? Look at here. Ax plus b is equal to t square. So t is equal to what? This square will go that side, will become square root of ax plus b. Clear? And this square root of ax plus b is written as what? Ax plus b to the power 1 by 2. So t cube will be what? It will be ax plus b 3 by 2. This is what t cube is equal to. So what do I get? 2ax plus b 3 to the power 2 3a plus c. That's my answer. That's how we get it. So all we have to think of is whatever is inside the square root, we'll take it as t square. That's what we need to substitute. Okay. So let us do question number 7. Let's do question number 7.